Sir, we are live now. Please start.
Sure. Good evening and welcome to the third live session of this course on deep learning for computer vision. We'll get started right away. So I think there are a few questions that some of you have submitted through the form that was circulated to you. Let me perhaps start with those questions and then I'll come to the questions that you all ask on chat. Please do feel free to submit questions on the form or on chat. I'll try my best to monitor both of them and answer them as we go forward. Okay, let me start with the first question that was submitted on the form. Harsha's, it's from Sri Harsha, who just comments that this was one of the best deep learning courses he has taken. Thank you, Harsha. Thank you very much for the words. I think it's for any faculty, it's always encouraging to know if a course is useful. Thank you very much for that. The second comment is from Arjun Pukale. Arjun's question is, in image-to-image translation models, like pix-to-pix, we pass an image of size 256 cross 256, and the output is of the same size. What if we need a high-resolution image, for example, 720 cross 720, both input and output? What is the best way to achieve this, keeping this in mind that the pix-to-pix model can be trained only on 256 cross 256 size images? So thank you for the question, Arjun. So the answer is, considering if you're looking for any GAN-based approaches, which pix-to-pix can be adapted with, I mean, at the end of the day, pix-to-pix does use a GAN-like loss. Remember that there are methods like big GAN and progressive GAN, which can go to very high resolution. So you'll have to see how do you combine a pix-to-pix with a progressive GAN kind of an approach. If you recall the lectures on progressive GAN, they learn in a progressive way. You first learn a low resolution image, learn to generate a low resolution image, then you improve the generation, and over iterations, you generate a very high resolution image. You can try to see how you can combine that in a pix. If you're very particular about pix-to-pix, you can do that to combine a progressive GAN approach with a pix-to-pix to get a high resolution. I think your broader question is also how do you generate high resolution images? You can also try to see if your input was anyway high resolution, you can try to change the architecture of pix-to-pix to meet that. If your input was anyway the same resolution, then you can change pix-to-pix architecture to meet your requirements. So one simple way you can do it is don't touch the architecture as it is, just add one layer in the beginning and one layer in the end. Pix-to-pix generator uses a UNet kind of an architecture, if you recall. So you can just add an initial layer and later layer, which comes down to say 256, and then try to see how it works. At least that would be my initial suggestion. Hope that was answers that question. The next question is from Mujtaba. Mujtaba asks, what will be the weightage of topics in the final exam and what will be the difficulty of the questions? Regarding weightage, there was no specific, the topics are from all over the course, right from the very first week till the last week. It is mixed up quite a bit. So it's not, I personally don't think it's weighted on a particular week. It's fairly uniformly weighted in terms of the contents across the course. In terms of difficulty, you could consider it similar to the kinds of questions you encountered in the quizzes, right? It could be of a similar nature. I think to a large extent, if you've understood the concepts, you should be able to answer these questions fairly well. The quiz questions difficulty is what you could expect even in the final exams. I do understand that I think there was one or two quizzes where the topics didn't match. Obviously, that won't happen in the final exam. So you can expect the difficulty level to be about the same. Okay, the next question is, comment is from Maharana, who says, all sessions have been interesting. The subject is vast. Thank you again for sharing your feedback. We would like to know some examples of CI tool for the implementation of medical image data. I'm not quite sure what a CI tool is here. I don't know if somebody can clarify that. on chat, I'll be happy to look at it. But his question says, would like to know some examples of CI tool for the implementation of medical image data. If you meant CV tool, computer vision tool, I think most of these methods can be used for medical image data also, right from image classification, segmentation, detection, depending on what kind of image data you're dealing with. And one of the earliest adopters of computer vision have been the medical imaging community. In fact, companies like Philips and Siemens have integrated machine learning and computer vision into their product lines way back in the 90s. I mean, going back to, if you see an MRI scan or a CT scan, the colors that you see for different regions that belong to different parts of the body, um, analyzing those kinds of things and doing a lot of other post-processing activities in the medical images has been there in these companies for a long time, actually. But for in a more recent sense, there are companies like Path AI, based out of the North America again, which are doing some excellent work in deep learning for medical data. So I hope I answered that question. But if oh, okay, Maharana clarifies computational intelligence. Okay, that's very broad. Right? Computational intelligence is very broad. But I think to some extent, I probably answered that question. To go back and see what companies like Philips and Siemens are doing. I mean, they are the large-scale manufacturers of the equipment that we see, the CT scans and the MRI scans and any new age scanning that you see, and trying to analyze the data and trying to help in diagnosis. At this time, we are not looking at systems that can replace a radiologist or a doctor. The idea is to how do you support their decision making as well as possible. So which means if a doctor, I mean, wants to see a particular layer of a scan, how do they see it? How do you color them differently? I think all of those things, significant amount of machine learning is used. And as I said, please do look at companies like Path AI. They are doing some really, really nice work. And that's a good company to see for their profiles. But I think in the context of medical imaging, there is so much more work that's being done too. It need not be just in a hospital sense. I think there are a lot of companies these days trying to use machine learning and computer vision for simple blood test reports, right? How do you compute the number of platelets? How do you compute the number of RBCs and WBCs in a simple slide on which you put a drop of blood, right? So all of you have had a blood draw perhaps, and you know that this goes to some laboratory where they analyze various different quantities and give you RBCs, WBCs, and platelets and so on. So how do you use machine learning in this process to do the counting and various other kinds of analysis is a significantly important topic for these kinds of companies. So there's an entire spread of where machine learning can be used in the medical imaging space. Hope I answered that to some extent at least. Okay, I think Adarsh points out there's also a homegrown Curie.ai. Thank you for pointing that out. That's right. Yes, I think there's a lot of work in India too. In fact, when I referred to the tool about blood test diagnostics, I think these are some things I have learned from local startups. I, in fact, had a conversation with a Hyderabad-based startup which wanted to collaborate to be able to use machine learning and computer vision to be able to count a lot of things like WBCs, RBCs, platelets, and all of that in an automatic manner. So that's a big space by itself. And as Adarsh rightly pointed out, I think there are a lot of companies in India today, startups, who are actively trying to pursue this as a core business. Okay, the next comment on the form is from Rishabh Lala. Okay, Rishabh, okay, these are general questions. Rishabh says, okay, first question is regarding top conferences such as CVPR, ICCV, NeurIPS, etc. Since I also review in these places, what do you look for as a reviewer that decides whether a paper should be accepted or rejected? If you can give a brief description about the process these conferences use to review a paper. Thank you for the question. I actually think this is an important question. And I say this as important because I feel India has a very small share of publications in top tier conferences. Most top tier conferences have a list of papers published by country. I think the most recently concluded NeurIPS had just 19 papers from India, I think, which if you look at many other countries, and for the population that we have, it's not too high. It's actually very few. Very, very few. So, but at the same time, I think India has exceptional talent. We all know that the same students who study in India, when they probably go abroad, start publishing excellently. So then an obvious question arises, why can't the same people, especially today with a large amount of democratization of knowledge, right? So you're able to sit in your homes, as long as you have a good internet connection, you're able to access pretty much the state of the art around the world with archive and many conferences going open source with their papers. Then a question, I think the key question is then, it's just that probably most of you have not been mentored about how to write a paper and what is the process of thinking about research to get accepted. So thank you for this question again, Rishabh. So it's a very, in general, the main thing any reviewer looks for in a paper is what's the contribution, what's the originality of the contribution, what's the novelty of the contribution, and how well has that contribution been studied, right? So this is the essence of how any reviewer looks at a paper. So what do you mean by originality? What do you mean by novelty? What do you mean by well studied? Become the sub questions. By originality, we mean obviously nobody else has done it. So which means when you write a paper, you have to ensure that you go through a very solid literature survey. You have read your papers, you read that space very well, and ensure that what you're doing is something nobody has attempted before. An important thing to also think through here is, can some other work that's already been published be looked at it this way, right? They may not have called it the way you're thinking about it, but another person who looks at it differently may say this is exactly that, this is just exactly that old wine in a new bottle, right? So in that case, you also have to learn to analyze it to ensure that what you're proposing is something different completely from existing work, from whatever perspective somebody looks at. Right? So that's the originality part of it. The novelty, in terms of the novelty of the contribution, it's about what impact can it have, right? So sometimes what happens is many papers get rejected because they are incremental, right, in the contribution that they make. So sometimes what happens is you take a paper that you like, you've read a paper, you find it very interesting, you take that paper, you take its code, maybe the code is available, you try it on your own data set, then you find that it doesn't work somewhere, then you add some alpha, beta somewhere. I mean, you probably change a few things here and there and submit it, and the result improves and you submit it to a conference. Unfortunately, for top tier conferences, this is not considered sufficient novelty. The novelty is largely incremental when you just take an existing body of work and just change a few things, right? So that by itself does not constitute novelty. So you also have to ensure that there's a significant amount of work that you have done beyond a previous work, which is different from what has been done. It could be based on an existing work, but just not one or two bells and whistles. You have to ensure that there's a significant layer of analysis on top of it, a novelty on top of it, which the reviewers should be interested in. And finally, as I said, the contribution should be well studied, right? This is probably the biggest reason why papers don't get accepted these days, especially, is because you've not compared against the right baselines, you have not looked at the right performance metrics, you have not probably compared with a large scale data set. So these are very, very common reasons these days for acceptance or rejection of papers. So when you start your experiments on any contribution that you come up with, I think the most, you need to ask yourself the question, you need to plan it. Actually, it's not something that you do it happenstance. You have to plan your research to say, what are the experiments I'm going to run? What are the methods I'm going to compare? What are the performance metrics I'm going to use to compare my methods against? And what are the visualizations that I'm going to use? Have I considered all the methods that my reviewer may want to compare my work with? Have I considered all the performance metrics that a reviewer may want to study my work with? For instance, let's say you're coming with a method for model compression, right? So you're trying to improve how small a model is. So then, and if you now compress your model and you start reporting accuracies of how well your model is doing, which is good. I think that's what is expected of a compressed model. But maybe what you need to also show is what is the compression rate you're getting? I mean, how much accuracy you're getting per bit or things like that, right? So you need to find ways in which what you're studying is well represented using an appropriate performance metric, right? So those are things to consider. So I think the third part, especially how well studied your contribution is is perhaps the reason that people get rejected the most. Sometimes you just may not have seen a paper and it happens that they are similar to yours or you've not compared against them. It's important that you compare your work against the latest and the greatest, and you compare your method on small data sets as well as large scale data sets. That's a very common problem again when people write papers. They probably run a few experiments on MNIST, CIFAR 10, CIFAR 100, things like that. But these days, we live in an age where that doesn't cut it. You probably need to have some results on something like Tiny ImageNet or ImageNet or something like that to show how well your method will work in the wild. Right? So at least those would be my initial thoughts to your question. So hope that was of some relevance. The second question Rishabh asks is, how should one go about publishing in these conferences if one is currently not enrolled in a master's or PhD program? What are the other alternatives to get mentorship? I think we visited this question in the last live session also. Yeah, I think that's one of limitations in India. I think the amount of mentorship we have is not as much as perhaps the other countries that get large amounts of papers in top tier conferences. So I would still say try to get mentorship. I mean, to the extent you can, that's important. And go to groups which consistently publish at top tier places. I mean, if it's important to go there because that's the peer learning that you get from being a part of that group is invaluable. Secondly, it's also about like joining hands with like-minded individuals, right? So I think I was mentioning this the last time too, is in your own college or organization, form a club, reading group, read the latest papers, focus on one area. I think that's important. Often when you're starting out, every new paper that comes out seems exciting, seems interesting. Like today, it could be, say, a particular topic, say zero shot or few shot. Tomorrow, it could be, say, quantum machine learning, who knows, right? So quantum deep learning, who knows? So it's important to stick to something for a while. Yeah, you should adapt to contemporary topics, but at the same time, you should stick to something for a while at least, so to be able to see results, right? So you pick a topic which you're interested in, focus on that for a reasonable period of time. I would say at least 1 year plus to start being able to deliver papers in that space. You have a long life ahead of you to broaden your portfolio and publish several kinds of papers, but it's probably important to start with good focus and publish there. At least that would be my initial thoughts again. Rishabh's third point is thanking for the course. Yeah, thank you again for the feedback. He also asks about a second course on NPTEL for advanced deep learning for computer vision in future. I'd love to do that. Maybe I'm not sure if this will happen in 2021. Our current focus would perhaps be to improve this course, assuming we'll offer this course next July again, would be to improve this course. I think some of the feedback that we got was this course was originally designed as an advanced course sitting on top of some people who've already done deep learning. So probably go one layer above. But I do understand that many students didn't have strong programming experience, say PyTorch or deep learning experience, which the lectures didn't really cover. So our immediate focus for the next offering of this course would be to actually introduce tutorials on the programming side, introduce videos on walkthroughs of the code and trying to cover that lacuna in this offering. That would perhaps be our immediate goals, and we'll probably add a few topics that come going from here till next year. But yeah, thank you for your thoughts. We'll definitely try to do that sometime in the future. Okay, the last question that I see on the forms is from Manisha, who asks, what is the difficulty level of the exam in comparison with weekly assignments? I probably already answered the question. It would be about the same level in terms of the quizzes, right? So about the same level as the difficulty level in quizzes. Okay, let me hop over to the questions on chat. I think the first question on the chat is Akash. Sai Akash asks, are there methods intended only for zero-shot learning? In the course, we have seen only methods that can be extended from FSL to ZSL and only one method for ZSL. Thank you. I think that's a nice observation in the course, and there was a very reason to do that. I mean, we didn't want to have too many lectures on few shot learning and zero shot learning in the last lecture. I think I was already receiving comments that there is too much to watch in every week. So we tried to cover as at least the last week was about breadth rather than depth. It was about trying to ensure that I cover as much of different kinds of new topics. So we didn't want to go more than one lecture on few shot learning and zero shot learning. And that's the reason it was organized that way. You are right. There are exclusive methods for zero shot and few shot. It's just that the lecture organized it in this way in trying to present one as a generalization of the other. But what was presented in the lecture is a fairly accurate analysis of where things stand today, right? So if you look historically, there were different methods for zero shot and few shot. But if you go to how things stand today, I think the way the lecture presents it is a fairly good assessment. So most of the works, because over the years, if you take a method like mammal or hallucination for zero shot, if you take a method like mammal, for instance, right? It was originally a few shot learning method, but today it's been adapted to zero shot learning, right? Similarly, there have been methods that have been proposed for zero shot learning, which have been adapted to few shot learning, right, over the last few years. So today it's very difficult to say that method in zero shot can never be used for anything else and is only a zero shot learning method. Over the years, people have adapted each of these in different contexts. So I think it's very difficult to pin them down like that at this time. But I think the lecture is a fairly accurate overview of where methods stand today. To a large extent, generative methods, that's the feature synthesis or hallucination methods, are probably the way to go with zero shot, because you have to generate your features for your novel classes. And for few shot, I think there are a bunch of different methods that work, and I think we try to cover them in a few different categories in the lecture. Hopefully that answered your question, Akash. Okay, then Sai Akash has another question, which says, is knowledge distillation different from network distillation, which we saw in self-supervision? Not really. They both are the same in this context. Knowledge distillation and network distillation are the same in this context. They're not different. I should probably just star that by saying that knowledge is is an open word. So today people use knowledge distillation for doing domain adaptation and things like that, to take knowledge from one domain and take it to another domain. So in that sense, knowledge distillation can be a broader term, but in the traditional way it was originally proposed, knowledge distillation and network distillation are the same thing. Okay, Adarsh, thanks. Thank you, Adarsh. Thank you for those nice words. It definitely motivates us to continue the offering. And as I said, we'll hopefully try to make this better the next time. I think Adarsh, next question is, will the coding tutorials be included in the next semester when there is a rerun of this course? Will the rerun be any different from this semester? As I just mentioned, we are tentatively planning a rerun next July, may not be in January, next July, but our plan is to have the programming component a little stronger, which was perhaps weak in this offering. We kind of know exactly what to do, but I'll stay away from describing that right now. But we plan to have video tutorials on more hands-on programming of the concepts covered in each of the weeks as part of the course. Topic-wise, I don't expect too much of a deviation from what was in this course into the next course, but for the programming part. But deep learning is a fast evolving field. So if there are very new trends that get developed in the next 6 months, we'll do our best to accommodate that in the next year's rerun. Okay, Duke says, I'm a third year EC student. I'm doing this course and it's challenging. How can I proceed after finishing my college in this domain? Yeah, as I mentioned, this course was meant as an advanced course if you have not done machine learning. And in fact, when we first created the course registration portal, deep learning, a prior course in deep learning was actually mandatory. We then removed it because we had some requests from students coming in. So yeah, if you have not done machine learning and are very new to this area, I would say this is not the first course to start with. This, I think, course is probably more geared towards people who have some background and want to get deeper or probably focus in computer vision a bit more. So I would only say, do more courses at your level, learn it step by step. Don't jump. That's what I would say, especially as an undergrad student. If you have not done relevant courses, I'm assuming if you're an ECE student, there are other topics that could also be new here. I mean, for example, the programming could have also been challenging for you. So I would only say take courses step by step and solve them. If you'd like to continue in your domain, the most important thing is to stick to it. Probably very similar thoughts as what I mentioned in the previous live session, which is take one of these topics, whichever excites you. Read a lot of papers, go these days, most of the papers that come out have code. Try your hands at code, upload your code on GitHub so people can see that you're an active contributor in this space. And then it will be a matter of time before you get picked to work on this domain, right? Be it in the industry, be it academia, wherever you are. Prashant says, I'm a research scholar working in recommender systems. I'm in a bit of confusion whether to work in probabilistic graphical models or in deep learning. Okay. I think today deep learning is, if you're, depends on what kind of data you're playing with, right? Even if it's recommender systems, I think it's important to understand what kind of data that you're playing with. If you're dealing with image data, NLP, text data, speech data, graph data, I think deep learning is inevitable. I mean, you have to learn deep learning. So if you're dealing with any of these kinds of data, I think today you have to use deep learning. They are the state-of-the-art methods, and at least for the time being, they're here to stay until a better method gets developed. So I would say deep learning is a basic course. Now, probabilistic graphical models is a choice, right? It's important if you choose to model your problem in a particular way, right? If you're going to choose to model your problem as a graphical network, where you say that each of your variables is a random variable and they all influence each other in a particular way. And if you think your problem lends itself to that kind of a modeling, then probabilistic graphical models is good, right? So, but it depends on how you choose to model your problem. That is what I would say. I do think probabilistic graphical models are interesting from the viewpoint of explainable deep learning. I personally think they can be used extensively for explaining the decisions of deep learning models, but that's a different issue altogether. I mean, if you're asking as which topic to learn, I think if your data is one of multimedia data, I think deep learning is inevitable. You can add other layers to it once you pick up deep learning. Okay, I think Prashant has a follow-up question. Is it okay to continue in the area of recommender systems as a lot is happening? Shall I get enough problems in this area? I think there are enough problems if you go deep enough, right? I think when you start out, it may look like, obviously you have to find the place, find the subspace where there is limited work, where a lot of people are focusing on these days. And that's where a lot of recent conferences help. I mean, if you work in the space of recommender systems, you should be looking at conferences such as SIGIR, Rexis, so on and so forth, where the latest and the greatest in these fields are presented. Go look at what are the trends there, right? So often you would find that the workshops in these venues actually provide the most recent trends because they are on cutting edge topics that are probably emerging, that a few people are working on and want to share with the broader world. So you can look at these workshops and tutorials and try to get a hunch of what sub-area of recommender systems is perhaps most interesting. And obviously, this should be a decision that you make along with your supervisor. If you're a research scholar, you're working with a supervisor, this is a decision that you should make by discussing with them. I mean, it also matters that your advisor should be interested in the topic and is interested in working with you and mentoring you on that, right? So that's also something for you to consider. Okay. Then the next question is from Adarsh again. For data sets with less number of images, what is recommended? Augmentation via modifying existing images or synthetic generation using GANs and VAEs? Hands down augmentation. There's no doubt about it. Training GANs with few images is still a research topic. I mean, there are still papers being published on training GANs with few images. As of now, GANs work well when you have large numbers of images. So I think trying to use synthetic generation using GANs when you have very little data for a domain is not a wise option at this time. It's definitely augmentation. And the interesting thing is the space of augmentation is so rich today, right? So augmentation is not just about using rotations, adding noise, changing the color channels, so on and so forth. Today you have methods like mix-up, and I mean there's an entire family of mix-up methods, manifold mix-up, remix. We have some work ourselves in that space where you try to interpolate data and then be able to work with that interpolated data as augmentations to your data set. I think that space of augmentations is quite big today. And when you have very little data, very difficult to train a GAN. So I would say augmentations is perhaps the way to go. I would in fact say smart ways of augmenting, not just rotations and translations and things like that. Those are image processing ways of or affine transformations of images. Look at more deeper ones like mix-up based methods and so on, and using those kinds of augmentations may be even more interesting. Then Rishabh asks, can you give us some details about new emerging trends that you believe are gaining momentum, which were not covered in this course? For example, you mentioned quantum machine learning. Quantum machine learning was just a topic that I just threw, just to say that we don't know what's coming in the future. That's what I meant when I used that phrase. But I think for a large part, we did cover most of the emerging trends in the last week. And if you listen to the last lecture, probably while we didn't get a chance to cover those topics, I think I did discuss a few topics that are hot and emerging in that space. So I would say to a large extent, we did cover most of the emerging topics in this area in the last 1 week. But I would say the same thing what I said to Prashant, which is go to some of the best conferences like CVPR, NeurIPS, ICCV, so on, and look at their workshops. You'll see trends of the kinds of topics that people are working on. That should give you an idea of what are the new topics that people are looking at. Right? I think that should give you a fair idea. Okay, then Rishabh asks, how many papers on average do I read per week? Okay, that's a difficult question. Reading happens in multiple ways. Reading happens while reviewing a paper, I'm reading a paper, right? While listening to a student, I'm reading a paper. While probably listening to lectures online, I'm reading a paper. While conversing with a colleague, it's a way of getting to know what a recent paper is doing. So probably at my stage in my level, I get it in different ways. And to a large extent, at least I think you shouldn't probably directly compare with me. You should be looking at where you stand. But my windows to knowledge are through the students that I work with. I think each one of them works on different topics, and they share papers, and we have active groups where we share papers and interact with each other asynchronously. So which means you just find a paper, we maintain a Slack workspace where we just post papers and everybody comments on it and so on. So those are ways in which we keep track of papers. And often if you've been doing a topic for long enough, it's not too difficult to pick up a new paper in that space. Right? So if it's a new domain that you've not been exposed to, then it takes some time to learn. But if you've been working on it for a while, then it's not too difficult to pick up new knowledge. Okay, and Sai Akash's question is, do we have methods that are a combination of zero-shot learning and GANs? In the sense, can we generate an image just given a novel class or a new text caption that the model has not seen? There are papers that do that, which have tried to do that. You can do it from semantic information like captions or attributes, as you just mentioned. But I think, I mean, it depends on what's your focus, right? So is your focus the GAN side of it, or is your focus the zero-shot learning side of it? As we discussed in the lecture on zero-shot learning. So I think the state-of-the-art methods in zero-shot learning are feature synthesis or hallucination based, right? So where for the novel classes, you generate images and then use them. But the trick there is to not generate images. right? Because when you do zero-shot learning, you don't need an image. You only need image representations, right? You only need to generate a vector that's a representation of an image. You actually don't need to generate an image itself. This is what zero-shot learning methods leverage, right? So instead of generating the image itself, you just generate image level features from attributes or captions or whatever meta information you have, and then use that for a downstream task. So I think it's important to consider, why do you want to generate, right? In many applications, I've personally experienced this in different discussions. In many applications, you actually don't need images. Images are for visual appeal, right? It's for us to look at and say, wow, right? It's not something that you need for applying a different, for let's say you want to do classification or you want to do some task on what you generated. Features are good enough. Right? You don't need a good looking image. You just need to ensure that your network can generate some image features for novel classes, and then you can just use that for whatever downstream task that you have, right? So it's important to decide what's your focus, right? And if your focus is not really about generating good looking images, uh, don't bother about it. Just generate features. That's a far easier task, and you can then use it for whatever you need to use it for. Okay, hopefully that answers Akash's question. Okay, I think that's about the questions we have. I know it's the last. Okay, there are a couple of things that have come on the form. Okay, I think it's just a repetition of the question on the chat from Prashant. I don't see further questions on the form or the chat. I do understand that this is perhaps, I know that for many of you studying in different parts of the country, this is exams week. So I do understand that, and it's also exam week for NPTEL courses. So if there are no further questions, we can probably close the session. I'm also happy to take more questions if any of you would like to ask. Aditya asks, are the questions in the final exam all MCQs? It could be fill in the blanks. I mean, it could be very similar to your quiz questions. So it could be, it is objective. Let me put it that way, right? These are objective questions. It could be fill in the blanks. It could be match the following. It could be MCQs. It's one of those, but it's objective questions. Okay, Duke asks, I did the prerequisite courses. I did a project using Siamese network for face detection. In a situation with two faces, I got my results pretty well, but with more than two faces, my confidence of prediction is about 90%, but it detects wrongly. What might be wrong here? I think it's difficult to answer without looking at the images and your architecture. I'm not sure why you're using Siamese networks for face detection. Siamese network is a face verification approach, not really used for detection. If it's face detection, I would say you should be looking at any detection method, faster RCNN, YOLO, SSD, RetinaNet, so on and so forth. So if it's face detection, that's what you should be using. So remember, Siamese network is a verification approach, right? You have an image, like from a passport picture or something like that, and then you have a web stream coming in, and you want to compare if the person on the camera here is the same as the person on the passport picture. That's when Siamese networks are most useful. There have been other variants, but broadly it's about comparing two inputs. That's when Siamese networks become most useful. So if you're only doing detection, I would say you should do, okay, I think now you're clarifying it's face verification. Okay, if it's face verification, yeah, I'm not sure. It depends on the kinds of images. I'm not sure if you had enough data to train your model. When you were training, was the loss going down or was it still staying high? Those are all things to consider. It's difficult for me to exactly tell remotely as to what could be the problem. It depends on the data. It depends on your model. It depends whether there was sufficient data. How much confusion is there between your faces? I mean, are you using it for twins that look alike or people that look very different? So unfortunately, it's difficult to say more remotely. Okay, so I would say, I mean, I'll be happy to answer it if you want to send an email with more details. But some of the things I'd say is, do you have enough data firstly, right? I think if you're only using some 5 images for each person, Unfortunately, these networks don't get trained. I mean, you should have of the order of hundreds or thousands at least to be able to train such models, at least with augmentation. And how many people are you trying to verify? How many are in your database? I think that's another question. What kind of a loss are you using, right? So that's also another question. If you're using the original loss proposed in Siamese network, there are far better ones. Please go back to that lecture and look at triplet loss, other variants of that entire loss space, triplet loss, ranking loss, all of that. Please see if one of them works a bit better for you. I think there are so many kinds of losses today. In fact, that particular lecture, if you recall, had a very nice reference at the end. It's a survey of face recognition methods that nicely covers different losses that one can use for face tasks. I would definitely recommend you to look at that reference to see if they improve your results. Okay. Let's see. One question from Rishabh again, which says, can you give a brief about federated learning for computer vision applications? Okay, that's an emerging area. Federated learning is the main idea. In fact, I can tell you that one of the groups that do federated learning around the world today uses data from Indian hospitals. So let's say you want to develop a model for detecting, say, cancer in CT scans or X-rays or something like that, right? So let's say you're a company or you're a lab, you want to develop a solution for this problem. And if you go to a local hospital, I mean, firstly, getting data is a problem. Let's say you go to a local hospital in your town, in your city, and then get that data. The problem is that data is going to cater to only that demographic, right? So it's probably people in certain demographics have a certain kind of reaction, a certain kind of tumor, whereas people with other demographics maybe have other kinds of tumors, right? So which means you have to be able to develop a model that generalizes across demographics. You need to be able to train your model across different people, maybe data coming from different hospitals. Now, one of your problems could be is the hospital may not be willing to share the data with everybody, or you may not get access to combine all hospitals' data and build a single model, right? So that's one scenario where federated learning comes into the picture, where the data are in disparate locations. You don't have the access to the data to bring it to a central location, but you want to still learn models across this data that are in different locations, right? So you could look at it as learning different models in different locations, different hospitals, and now trying to glean out a common model that works on different settings. So a closely associated concern with federated learning is the privacy issues that come to, right? So there could be data in a particular server where, due to privacy issues, that data cannot be brought on to a common server, say sitting in your location. So you may have to run the model only on that hospital server in their location for whatever reason it may be. Hospital is just an example for this particular case. It could be any other domain where privacy is important. So that's a use case where federated learning becomes extremely important. And I hope you can imagine the rest, right? You can imagine that for many other applications, there are data that are sitting in different pockets around the world, and for various reasons, maybe for feasibility, for privacy, the data cannot be pulled out of their locations. They have to be only in those respective locations, but you still want to learn a generic model across this data. Okay, that's a standard use case for federated learning. Okay, so some of the recent topics is now how do you do SGD in a federated setting? Like those kinds of things could become important topics. There are a few other ways in which you can do this. There's also a variant called split learning, which a few researchers at MIT have been doing. That also does something similar to federated learning, but it's just called split learning. So you can also follow that group if you're interested. Okay, Duke says, but we can't collect hundreds of images for a single person. Yeah, I mean, so if you cannot collect hundreds of images for a single person, you have to use augmentation methods. But if you cannot do that, your method won't do well, right? So that's something you have to consider. So you have to ensure that when you use deep learning for a problem, you have the necessary data, right? Otherwise, it's difficult to use that to solve that particular problem. You can consider methods where you get some representation using a pre-trained network and then do a cosine distance similarity or something like that. You can probably do something like that with when you have very little data. But if you want to train a Siamese network, you need data. And unfortunately, at least with augmentations, you need reasonable amount of data. And unfortunately, very difficult to compromise on that. Okay, Pawan asks, what is meta learning? Okay, that's a valid point. I think we did talk about it, but probably didn't exactly describe it in the slides. Meta learning, as the word says, means learning to learn, right? So it's meta learning. So you're learning to learn something, right? So you're not learning something, you're learning to learn. That's what meta learning is about. So in fact, for a large part, this space was opened up by a work called MAML, Model Agnostic Meta Learning, which is one of the methods that we covered in the first lecture, if I'm right, of week 12. So how do you, I mean, so in that particular work, there are several variants of meta learning that you can think about. But in that work, what meta learning meant was, how can I learn a model which, if I have few data points for a particular task, for a particular class, I can quickly fine tune. Right? Why is it called meta learning? Because if you go back and see the algorithm for MAML, you'll actually try to see that the way the SGD is done, the parameters are learned, is on a gradient descent on a parameter space, on a loss with respect to other parameters, right? So that's what brings the meta angle to this, right? Go back and look at the algorithm for MAML in the first lecture of week 12. You'll actually understand why it's called meta learning. If I'm correct, I mentioned it in the lecture if I'm right, but you're learning to learn in that particular context, right? So there are other methods too, where meta learning is used, where people operate in the parameter space, right? So once again, this is one place where we ourselves, my group here at IIT Hyderabad, also has a few papers where we try to learn models whose outputs are model parameters, right? So, and those model parameters can then be plugged in to architectures to solve problems. Okay, so that's also meta learning, very broadly learning to learn, right? Where you're trying to learn some way to generate model parameters, which can then be used fine-tuned to a specific task. That's broadly meta learning, right? Meta learning is obviously a broad term. For a couple of years, it was referred to only few-shot learning, the way MAML did it. But I think today it's more broader in what meta learning is. Meta learning is broadly about learning to learn in various contexts. Rishabh asks, are there startups in India that are working in research setting? Oh, plenty of them. I think it's difficult for me to list all of them. I'm quite sure I'll miss out a few. I'm not sure where to start. I think there's Wadhwani AI that sits in Bombay, that's doing some excellent work in using deep learning and computer vision to a lot of applications for social good. Then there is Match Street Den in Chennai. I think there are just so many. I think there's Curate.ai, as one of you pointed, I think Adarsh pointed out. I think there are quite a few. You should just Google and see. I mean, there's Drive Buddy, which is a company from Pune that works in autonomous navigation. There are plenty of them. In fact, I wouldn't even want to get started on this. You should just a simple Google search, spending some time on it, should reveal you enough startups. There are plenty of them today, I think, which is nice to see. I think India's, there are a lot of people trying to be entrepreneurial, especially in this high-tech space, in the deep learning, AI, computer vision space. And hopefully those mean good things for us. Okay, let me see if there are any other questions. Okay, I don't see more questions here, both on the form or the chat. Okay, if no further questions, we can probably close the session here. And thank you all for joining this session. Thank you for being, okay, there's one more question that just came in. Manisha asks, is face recognition good research topic for PhD students? Okay, so I mean, I wouldn't want to become your advisor. I think you should definitely talk to your supervisor, whoever is advising you for PhD. But face recognition is a pretty old topic, right? So I think you should focus on one aspect of it. Maybe, I mean, I'm just throwing out options here. Maybe federated face recognition or face recognition uh, in very low resolution images, or where only you have CCTV camera and the face image is not more than 20 by 20 pixels or something like that. I think you have to constrain it in some way to make it a more interesting research problem, right? Because as by itself, face recognition has been there for a few decades, has been commercialized by companies in several ways. Obviously works in constrained settings, does not work everywhere, but has been tried. So you have to find a way to add a contemporary aspect to it when you pursue it as a research problem. Uh, Adarsh asks last minute tips for the exam. Yeah, no specific tips as such. I mean, if you've followed the course well, if you've understood the concepts, I would just say go through the quizzes again. That's about the tips. I mean, that's if you've understood the course and followed the concepts, I think the exam should be fairly simple. That's the only tip I have. Otherwise, it's objective. It's not something that you have to mug up and keep. If you've understood the concepts, it's not difficult. The exam should not be difficult to solve. Okay, Pavan has one more question, which says there are a lot of talks on adversarial attacks in computer vision. The mitigation of it asks lots of data, which may not be possible to have. Do you think this worries? Of course, yes. I think adversarial attacks are an important problem, especially for safety critical applications, right? Maybe for a lot of applications where we directly use computer vision today may not be, but anywhere where safety criticality or risk is involved, I think adversarial attacks are extremely important, and it's definitely a cause for worry unless we solve the problem. To some extent, we've solved it using adversarial defense and adversarial training and those aspects, but they are cumbersome. They do require a lot more training time to train these models. So that is a constraint at this time. So I think this is still an open topic at this time. Maybe mainstream hackers have not focused on this yet, which is perhaps the reason why we don't see it. But I think it's an extremely critical topic. I mean, imagine a self-driving car which is using a computer vision method to segment and detect objects in the scene. Imagine now that you have a red signal on a traffic light, and by an attack, one of the hackers makes it look like green to the car, right? So that's directly going to cause an accident and potentially lives or fatalities, right? So it's extremely important, no doubt at all, right? A small change could cost lives. So, and it's still an open problem. Hopefully we'll solve it very soon. Okay, I think no further questions at this time. So we can perhaps conclude the session. So once again, yeah, thank you for participating today. Thank you for being there with the course and all the feedback, and all the best for your final exams, and hope many of you go on to pursue really good research in computer vision. Wish you all success. Thank you.